In this video, we're going to look at transformations of our logarithm graphs. So let's quickly review what we've learned about transformations. So we've done it with square roots, we've done it with quadratics, we've done it with exponentials. I guess just do it like this. All right, so any number that's close to your x, so it's like directly subtracting your x, that's going to move you left or right. And then any number that's away from your x, all right, so it's kind of separate from after the function part, that's going to move your graph up and down. And the final thing is if I put a negative in front of everything, that just flips my graph upside down. All right, so those are the basics. Knowing things near x move you left and right. Numbers away from x move you up and down. All right, so here's one we're doing with a square root function. So it's always important to know what's called your parent function, the kind of function you're starting with before you transform it. And if you look at this graph, the interesting thing you see is the square root. So our parent function is the square root graph, which looks like this: 4, 2, 9, 3. I'm just taking the square root of the number. This is my just normal square root graph. If you ever forget what a graph looks like, you can always just make a t-chart, plug in some values. And then what's going to happen for this graph, I'm going to take my graph and I'm going to shift it left 2. So the one in the inside is the annoying one because it's the opposite of what you think. So it's going to move my graph left 2. And I'm going to move it down 3. So now my graph is going to start at this point. And then this negative is going to flip it. So instead of going upward, it's going to down. So let's move it first. All right, so this is going to move left, and then down. All right, so it's the exact same shape of my graph, just moved around. And then I can't do it with the little draggy thing. The negative is just going to flip it upside down. So instead of going up to the right, it's going to go down to the right. And that would be my graph of f of x. All right, so I want to see you move it in the right place. There's a negative, you flip it. I've got e to the x minus 2 e. We haven't learned about e, so I'll put in let's make this 2. 2 to the x minus 2 minus 3. All right, so we can start with our parent function, our 2 to the x. Again, that's the kind of interesting that happens is 2 to the x, and then some other stuff happens after that. So with 2 to the x, we know we have a horizontal asymptote there. We know we have the point 0, 1, 1, 2, 2, 4, and so on. We know it's kind of flat to the left and then curves up. Like if you ever forget what a graph looks like, you can always just plug in some values. And then what's going to happen, now I'm going to move right 2, down 3. The interesting thing we learned with the exponentials is when it moves down, the horizontal asymptote also moves down, so it's going to move down 1, 2, 3. So now my horizontal asymptote is down there because the whole graph moved down 3. Oops. Like for some reason it won't let me drag the whole thing, so I'll just draw it again. All right, but this whole graph is going to move down 3 and then right 2. All right, so now my graph is going to start there. My final answer is going to look something like this. All right, flat to the left of that starting point, and then it's going to turn up after that, something like that. All right, so this is my graph of f of x. All right, it's always important you know what the parent function looks like, the kind of original function if I hide the subtractions and stuff. All right, so 2 to the x, that's my parent function, and then I move it around appropriately. All right, so now we're just going to do the same thing with logarithms. All right, again, the things that are close to x are going to move me left and right. The things that are far away are going to move me up and down. All right, so you can just tell logarithms are even easier in that sense because there's these parentheses that really tell you like this is the left and right thing, this is the up and down thing. All right, so let's graph log base 2 of x plus 3 minus 1. So let's graph the parent function first. I kind of ignore the plus 3 and the minus 1. So my parent function is log base 2 of x. All right, so we know with our logarithms there's a vertical asymptote. We know there's the point 1, 0. And we know because this base is bigger than 1, it's going to be like a straight line basically at the bottom here before it curves up like that. And now what's going to change? All right, I'm going to move everything to the left 3 because it's plus 3 near the x. So everything's going to move left 3. And then everything's going to move down 1. So this point here becomes that point. Again, the really important thing is if everything's moving left 3, this vertical asymptote is also going to move left 3. So 1, 2, 3. All right, it doesn't matter if I move the vertical asymptote up or down because you can see it's still a line going straight up and down. So all that matters is the left part moving it left 3 to there. Oops, actually get it on the right place. Come on. All right, but then other than that, my graph should be exactly the same. It's kind of a straightish line at the bottom until it hits that point where it starts to curve. So that's my function, f of x. So when we're doing exponentials, it was really important to get that horizontal asymptote in the right place. And now with logarithms, it switches to a vertical asymptote. That's one of the more important things to make sure we get correct. All right, here we have negative log base 1/3 of x minus 2 plus 4. Again, kind of ignore everything except for the x at the start. So we're just going to graph log base 1/3 of x, put in our vertical asymptote, put in the point 1, 0. This is a smaller base, so it's going to be at the top to start before it curves out. And now we want to move this graph right 2, up 4. All right, it's just going to move this point right 2, up 4, and it's going to start there. That's just my kind of a new starting point. Again, if I'm moving stuff to the left or right, this vertical line is going to move as well. So I need to move this right to there. Let's get on 2. There we go. And then this would be my graph. I'd be vertical at the top before I curve through here. But this is not my final answer because there's one thing I haven't done yet, and that's the negative sign. So the negative sign, again, just flips my graph upside down. So instead of being vertical at the top, this one's actually going to be vertical at the bottom. Let's do it in black. Going up to that point, and then turning through. All right, so this will be my final graph of f of x. All right, so left and right is the really important one for logs. So you're moving that asymptote up and down. And if there is a negative, just make sure you're flipping kind of whether you start on the top or start on the bottom. All right, so here's one for you to try on your own. Go ahead and graph this one. I'll show you the answer in 3, 2, 1. And your answer should look something like this. So when I go left 5, my asymptote slides to this asymptote here. I'm going down 3, so my original point 1, 0 switches to here. And then 3, the base is a bigger number, so it's one that starts on the bottom and goes up. If it was the exact same problem with 1/3, it would start here and then go down. All right, so the transformations happen the same way as we learned before, still going left and right, up and down. Make sure you get your vertical asymptote in the right place. The vertical asymptote is a really important part of the logarithm graph, just like the horizontal asymptote was a really important part of the exponential graph. All right, so make sure you're putting that on your graph as well as a dotted line.